So we look at this. Number 9, you are given a matrix here. So your matrix here, they said the cofactor of this matrix is this. Okay, so determine what's the value of x and y. So you're going to find out what is your cofactor 1, 2, which is x plus y. What is your cofactor 3, 2, which is x squared. Okay, so row 1, row 2, row 1, row 2, row 3, column 1, column 2, column 3. So this is original matrix. Cofactor. Concept of cofactor is plus or minus for your minor. So for this unknown here, the cofactor here means it will ask you to find your cofactor 1, 2, which is equal to x plus y. Another unknown, cofactor 3, 2, which is equal to x squared. So what is cofactor? What is your cofactor? Cofactor is equals to plus minus for your minor. So what's your minor? Minor, you're going to cancel out the row and the column, corresponding row and column, and going to find the determinant for these remaining entries. Okay, so for cofactor 1, 2, it will be in the position of positive, negative, positive. So position in negative. So negative, positive, negative. So here is negative. Cofactor 1, 2 is equal to negative minus 1, 2. So I doesn't need to do every cofactor because we are going to find the missing cofactor only. So we just straight away focus on this cofactor 1, 2 and cofactor 3, 2. So continue. If I want to do my minor, I'm going to cancel row 1, column 2. So the remaining will be 2, 2, negative 3, negative 1 is equals to xy. So determinant of this 2 by 2, it will equals to AD minus BC, which is negative 2 minus negative 6. Therefore, our first equation will get x plus y equals to negative 4. So this is our first equation. So we cannot solve yet. We see another information here, cofactor 3, 2. When we come to cofactor 3, 2, we identify whether it's positive or negative. So positive, negative, positive, negative, positive, negative. Then this one is positive, negative. So it is a negative for minus 3, 2. So minus 3, 2, we're going to eliminate row 3, column 2. So the remaining entries here is 1, 2, negative 1, negative 3, which is equals to x squared. So x squared is equals, we're going to do our AD minus BC. So this is negative 3 minus negative 2 equals to x squared. So x squared will equals to 1. So when I put x, it will become positive, negative, square root of 1. So x will equals to 1 only because it said x should be greater than 0. We will not take two answers. We will not take both answers because x greater than 0 means positive answer. So we only accept x equals to 1. So we will substitute x equals to 1 here. 1 plus y equals to negative 4. So y will equals to negative 5. So this is how we do our cofactor concept. So we see here what is the important concept here. So first of all will be how we express our cofactor, which is this cofactor for both information. This is our concept. For this just formula only. So we have to see how you apply your concept. And then find out your answer, x and y. Okay, so we go for part B here. In this section, they said they're giving you information that if a formula for matrix matrix A squared minus 4A plus I equals to 0. So when we doing matrix, we don't assume it as algebraic. Okay, so doing matrix, the multiplication is very important. Where matrix multiplication, AB doesn't same with BA. So for every step of multiplication, we have to write it very clear. So for A square means the matrices is taken by A times A minus 4A plus I equals to 0. So all these are matrices. They ask us, this question asks us to show that how we come to A cube, and hence means using the information given here, how we obtain our A3. How we obtain our A3. So first of all, we apply our properties first. How to get to A cube means we're going to time A. So when you times the A in front here, so it will go to every entry time in front of the matrix. So I times the matrix A in front of AA. So 4 is a number, doesn't matter, we can skip 4. Then time a matrix in front of a matrix plus time a matrix A in front of identity matrix. So we have to show it when we do multiplication, when we time, we go to in front for every matrix. So means that we are taking row for the first matrix, column for the second matrix. So when you do it inversely, it will be different because this is taking row, this is taking column, this is taking row, this is taking column. So their multiplication will be different. So we have to show it how to get to A cube. So multiply in A in front here, A in front the matrix, A in front the matrix. So here we can show that it will become A cube minus 4A squared plus. So the properties of A times with identity. We will go back matrix of A. This is our properties of our matrices. When our A inverse times A, we get identity. When our matrix times identity, we get back that matrix. So when our matrix A times identity here, we will get back our original matrix A. So by the way, we can see what we need to show is A cube equals to 15A minus 4I, so it doesn't reach that stage only. What can we see here from the equation? We can substitute our A squared is equals to 4A minus I. So we will substitute here. A squared equals to 4A minus I, so that A cube will become the new form of the equation like this. Then we expand. So multiply your numbers with numbers, doesn't matter, it gives you negative 16A, then negative 16I, yeah. So 16 is a number and the matrix is still 16I. It will not getting I because it will be like that, 16I. So it will still 16I. It will not become I only. If it become I only, that will be not logic because I am multiplying 16 inside, so it's still 16I. So you must be very clear what is your number, what's your matrix here. Then we continue, we still have a plus matrix A here. So A cube will equals to, we operate this one, 16A plus A negative 15. Move to the right hand side, it will become positive. Oh yeah, I get a 4 here, yes. Over expand. Wrong substitution here, so it should be an I here. So when I multiply in the 4, so I get positive 4. move to the right hand side, minus 4i. So this is how we shown it. So for the next part, we're going to find what is our a cube. So you don't go and substitute a times a times a. You say hence. Hence means you have to use this result. Means I'm going to find my a cube using this result, which is equals to 15 times matrix A minus 4 times identity. So identity is 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Matrix A, we can refer back our original question here. This is our matrix A, so we're going to substitute this matrix A into our equation here. Okay, so get to the final answer. What is that? So do your multiplication. 15 minus 4, you equal 11. And then 15 times 2, 30, minus 0. Then negative 15. Then 1 by 1. Then 30 minus 0, 30. Here, 45 minus 4, 41. Then negative 45. Then times 2, 30, 30, and negative 90. Okay, so from here what we want to see is how you apply your concept. Means concept of multiplying in front of each matrices, and then we to get until this stage, then we substitute the information here, a square, and manage to prove your answer. So finally apply your 15a minus 4i to get your matrices a cube.